Problem number 19 from the ACP review concerns the graph of a quadratic function. We've seen only one quadratic function in class, and I want to make sure I reminded you of what that was. In particular, the parent quadratic. Yeah, let's see if I can just show it here. This is the standard form of quadratic. You won't get to this until next semester. But let's look at, this is more like what we did in class. This is what a quadratic, the graph of f1 of x equals x squared looks like. It's this curve. Notice that it is symmetric about the y-axis, and notice that it has a lowest point, and this particular one has a lowest point, which we call a vertex. And there are certain things that happen with a quadratic. You can't see the a value. A value is the coefficient of the x squared term, and in this case is 1. You can't, but we don't need to write a 1 in front of x squared. So there's a 1 in front of the x squared. You can't see it. You don't notice it until when a is bigger than 1, or whenever a is positive, the quadratic looks like this, and the vertex is a minimum when a is, and so you see the vertex here, and there's the line of symmetry, the actually axis of symmetry, and you see that it's symmetric about the axis of symmetry, and there's your vertex there. And again, this is the parent quadratic function, the one from which all the other quadratic functions come from. Okay, look what happens when a is negative or less than 0. Then the highest point is called a maximum. The quadratic has a maximum quadratic, and there, look at the parent function when we flip it, and now it's negative x squared. Now the vertex is the highest point on the curve, and it's a maximum point. It's also called the vertex. The vertex is basically the same. It's either the maximum or the minimum point, but it's also called the vertex. And you see the axis of symmetry didn't change. Okay, and the vertex is now the maximum point. Okay, so look at for example, in this curve, there is a y-intercept because this is the y-axis. There are 2 roots or zeros. We call these zeros. Notice that if you remember, the zero of a function is where y is equal to 0. And so there are 2 x-intercepts or zeros because this quadratic hits the x-axis twice at -2 and -4. So we call those zeros or solutions or x-intercepts. And there are 2 solutions. We call that, there are 2 solutions to that quadratic. So, and the axis of symmetry and always goes through the vertex. That's important to know. The axis of symmetry is always goes through the vertex, or the vertex is always on the axis of symmetry. Okay, so that's a little bit. Here's some other examples of y-intercepts on parabolas. There is a vertex there, and the vertex happens to be also one of the solutions, the x-intercept as well, and your axis of symmetry. Okay, and here's another one where you have a y-intercept, but look at this. This particular curve, parabola, never hits the x-intercept. So there, x-axis, I'm sorry. So there are no roots to this. There's no roots to this quadratic. Okay, axis of symmetry goes to the vertex. Okay, now that said, let's look at the problem that we have, that we were looking at, and go back to it. All right, so here is the graph that we've been given. All right, if I can move things around there, I guess I can hide this. Here's a graph that we've been given. And if you look at this graph, you can see that there are 2 zeros or x-intercepts. There's one, we don't know exactly where it is, but we see that it's between -2 and -1. And we can see that there's another 0 between 4 and 5. And you can tell what I'm looking at. Actually, I'm going to put like a little star right where I'm looking there. And let's see. So I got a root here, and let's clone that. And then I got another root right here, another 0. So I got 2 zeros. So based upon the graph, between which two values of x is a 0g located? Is there a 0 of g of the quadratic function g between -9 and 8? We can't even see that. It's not even, we don't, that's way out here somewhere. 1 and 2. No, nothing's happening there. -7 and -5. Again, we can't see that. But 4 and 5, there's our root right there. We also have a root between -2 and -1, but they didn't ask that. They just want to know. So the correct answer to this problem is really, there's nothing to calculate, it's just everything to see. And I'll go ahead and let's just go ahead and just indicate that with a line right there. So our correct answer is D, 4 and 5. We have a root right there.